The pace of AI advancements, it really feels like an unrelenting current, doesn't it?
It absolutely does. A data stream with no back pressure, as you put it.
Yeah, just when you think you've caught your breath, there's a whole new wave.
Mm-hmm.
So today, we're diving into AI News June 24, 2025, the pulse of a planet racing toward machine intelligence.
Sounds about right.
Our mission, like always, is to try and cut through all that noise, pull out the really important bits, the insights, and maybe add that human context you need to, well, make sense of it all.
Giving it the human metadata it deserves.
Exactly. A shortcut to staying informed. This deep dive, it should be quick, maybe a bit witty, and honestly, occasionally a bit terrifying.
That tends to be the case these days.
We're covering a lot: brain science, battlefields, biology, even courtrooms.
And what's really striking, I think, is how interconnected everything is becoming.
Right.
It's not just isolated breakthroughs anymore. You see these seemingly separate fields, cognitive science, biotech, defense, law. They're all weaving together now, and AI is the thread.
It really is becoming the connective tissue, isn't it?
Absolutely.
Okay, let's start with something. Well, a jolt from Cambridge.
Yep.
MIT's Media Lab.
Ah, yes, the ChatGPT study.
That's the one. Looking at how our brains react to it. So they had 54 volunteers, hooked them up to EEG caps, gave them a task, write an SAT essay, but they split them into 3 groups.
Okay.
One group just wrote by hand, old school. Another could use Google for help. And the third just straight up used ChatGPT prompts.
And the results were pretty stark.
Tell us.
Well, those brainwaves, the alpha, theta, and delta rhythms, the ones that usually light up when you're, deep in creative thought or problem solving,
Yeah.
they essentially flatlined for the group only using the chatbot.
Flatlined. Wow.
And the English teachers who reviewed the essays, they called the outputs soulless, which, coming from MIT, that's quite a statement.
Soulless?
Yeah.
And there was more, right?
Yeah.
About memory.
Yes, that's maybe even more concerning. When those same people later tried writing without AI, their recall was worse. They couldn't really remember what the AI had produced for them.
Suggesting they weren't truly engaging with the material.
Exactly. A lack of genuine cognitive engagement.
But here's where it gets really interesting. There was a twist.
The crucial twist, yes.
Students who drafted by hand first and then used ChatGPT just to polish or refine.
Their neural wiring lit up completely differently.
Right. It points strongly to this human first, AI second workflow.
It really does, and it highlights something critical. The order in which we use these schools is not trivial. It really matters for learning, for cognition.
So it's not about just offloading the work.
No, it seems using it as a refinement tool might actually enhance our thinking, working with those existing pathways. It's about the quality of the engagement.
Okay, so that's the limits of our engagement. What about the limits of the models themselves? We're talking about large language models.
Ah, right. That leads us neatly into position bias, why transformers forget the middle.
Another MIT insight.
Well, researchers generally have identified this. Large models, they tend to remember stuff at the beginning and end of long text inputs better than the stuff in the middle.
Like when you read a long article.
Sort of, yeah. The technical reason involves something called causal masking and the deep stacks of attention layers. Basically, the way the model processes information means the signals from the middle can fade.
Okay, so why should you, our listener, care about this?
Well, if you're building tools that need to understand long documents, think legal contracts, medical records, this is critical.
Because
A crucial detail, a key clause buried in the middle might get overlooked by the AI.
And lost paragraphs can carry real liability.
Precisely. Huge implications there.
All right, let's shift gears. Let's look at how AI is speeding up discovery in science and health. Because the pace here is just wild.
It really is.
First up, back to MIT again, Boltz 2. They're calling it drug discovery at warp speed.
Yes, Boltz 2 is impressive. It offers something like 1,000-fold speed up in guessing binding affinity.
Binding affinity. That's how well a drug molecule sticks to its target.
Exactly. Traditionally, figuring that out involves these really heavy physics-based simulations. Very slow, very expensive.
And Boltz 2.
It skips a lot of that. It uses deep neural networks trained on massive data sets to predict the affinity. It's learned the patterns, essentially.
A shortcut.
A very effective one. And the best part, you don't need a supercomputing cluster. A standard workstation DPU can run it.
That's huge for accessibility.
It is. Plus, it's open source permissive license. It really is like a cheat code for biotech labs, big and small.
A cheat code, I like that. So these early drug screens that used to eat budgets and take weeks.
How compressed into a coffee break, potentially.
Yeah.
It's a massive efficiency boost.
Incredible. Okay, next, cancer detection. FRAGL, hunting tumors in a teaspoon of blood. This is from Singapore's Genome Institute.
FRAGL is fascinating because it's elegantly simple in concept.
How
The AI just spots patterns in the length of DNA fragments floating in the blood. See, DNA shed from tumors tends to have different fragment lengths than healthy DNA.
No complex chemistry needed?
Not really. It's mainly sophisticated pattern recognition on those size distributions. And this approach, it could drop the cost per test dramatically.
Dramatically.
From around $700 down to under $40.
$700 to under $40.
That's the projection. It makes frequent monitoring much more feasible.
Which means?
Doctors could track remission status almost in real time. It paints a picture where, oncology visits might eventually feel more like routine checks, like getting your blood pressure taken.
That's a powerful vision. And sticking with health, physical rehab, Angel Suit H10, exoskeleton therapy gets smarter.
Right. This is from Angel Robotics in Seoul. It's a certified, powered orthopedic device.
So it helps people move.
Exactly. AI estimates the user's intention. Are they trying to walk, stand up? And then motors provide assistive torque. It's designed for people recovering from strokes, spinal injuries, or managing Parkinson's.
Tailored support.
Precisely. And crucially, it digitizes everything. Every gait variable gets logged, giving therapists incredibly detailed data to track progress.
You can easily see home versions coming soon.
Absolutely. A rehab robot in the closet could become as normal as having a treadmill, making therapy much more accessible.
Okay, let's pivot. Let's talk about the infrastructure, the hardware that's actually making all this AI expansion possible.
Oh.
And surprise, surprise, we're back at MIT.
They are definitely on a roll.
Lightspeed in silicon. MAFT-ONN and the road to 6G. What is this?
This is a photonic chip. It actually performs neural network math using light, literally at photon velocity.
Okay, break that down. How fast is that compared to normal chips?
Well, a digital signal processor might take microseconds for certain operations. This photonic chip, it does things like spectrum inference in nanoseconds.
Nanosecond.
And it does it while using way less power. We're talking maybe 100-fold energy saving.
They mentioned cramming 10,000 neurons on a fingernail.
That's the kind of density we're looking at, yes.
So what does this mean for, say, drones or self-driving cars? Edge devices.
It means that gear out in the field, drones, medical implants, driverless pods could make complex decisions almost instantaneously in real time without killing their battery.
Real-time AI on the edge.
Exactly. And they're already looking at putting transformer models, the kind used in large language models, onto these photonic wafers. Imagine literal beams of insight zipping through fiber optic cables.
Yeah. Okay, scaling up from fingernails. SoftBank is talking about $1 trillion robot desert.
That's Masayoshi Son's latest huge ambition, yes. He's apparently in serious talks with officials in Arizona.
For $1 trillion.
A $1 trillion AI and robotics complex, potentially bringing in giants like TSMC, maybe Samsung.
What would that look like?
Imagine gigafactories churning out chips alongside assembly lines, building humanoid robots. It's a massive bet on automation to address labor shortages. Silicon muscle replacing human muscle on a huge scale.
And speaking of scale, let's look at cars. Connected cars speed toward a $27 billion AI market.
Yeah, the analysts are predicting that AI revenue just from connected vehicles will triple within a decade.
What kind of AI are we talking about in cars?
Oh, all sorts. Machine learning predicting when parts might fail. Computer vision reading road lanes, signs, pedestrians for autonomous or assisted driving. NLP, natural language processing, understanding driver commands.
And V2X.
Right. Vehicle-to-everything communication. Cars talking to each other, to infrastructure, constantly beaming data back and forth. North America leads the market now, but Asia-Pacific is growing fastest.
Are there speed bumps on this road?
Definitely. Semiconductor supply chains are still a concern, and privacy laws are a big evolving challenge.
So it needs policy work as much as engineering.
Absolutely. You need as much work on policy frameworks as you do on the firmware itself.
Got it. And while we're on things that move, robots themselves. Honor and Unitree break the robot sprint record.
This is interesting. Honor, the company mostly known for smartphones.
Right. That seems like a pivot.
A big one. They have this initiative, the Alpha Chai Plan. They took a Unitree humanoid robot that's a third-party chassis and used their own new algorithms to push it to run at 4 meters per second.
4 meters per second. That's fast for a humanoid.
It is. It signals honors move into what they call embodied intelligence. They're focusing on the software, the AI brains, partnering with hardware makers.
So you can picture logistics bots zipping around warehouses, maybe even weaving between pedestrians someday.
Or industrial robot arms that learn new tasks on the job. That's the direction this is heading.
Okay, let's broaden the lens now. AI's societal ripples, policies, security, law, global dynamics. Because these changes, they touch everything.
They really do.
Starting with a big headline, Pentagon bets $200 million on OpenAI for government.
Yes, a one-year deal, $200 million. OpenAI is tasked with building prototype tools for the U.S. government.
For what kind of tasks?
Everything from helping triage intelligence data to automating paperwork. It seems to connect to a much larger project called the Stargate Infrastructure Push.
Stardate.
Apparently a $500 billion joint venture involving OpenAI, Oracle, and SoftBank. Big money, big players.
So beyond the massive numbers, what's the real signal here? What does this mean for us?
I think the clear message is that national security is now being directly equated with AI model throughput and capability.
Which raises some serious questions.
Absolutely. How do you govern these models? What about data privacy inside government systems? And the whole issue of militarizing generative AI, using it for defense applications, it's a major shift.
And on the global stage, competition is fierce. DeepSeek R1, China's open source cannon.
DeepSeek R1 is definitely making waves, trained on a staggering 7 trillion tokens.
7 trillion.
And it handles a 128K context window, which is very long. It can process a lot of information at once. Reports suggest it's challenging models like GPT-4 on logic tasks.
But the key is open source, right?
That's the crucial part. Unlike some other top models, developers can access DeepSeek's weights directly. No gatekeepers. The code is free. The license is generous.
Making it highly accessible.
Extremely. There are even whispers, unconfirmed of course, that some outputs from Google's Gemini might have been used in its training data.
Interesting. But the bigger implication seems to be that powerful open source models are now truly hitting the mainstream.
It feels like a significant tipping point, yes.
Okay, but with all this power comes, well, the darker side. GenAI weaponized, cybersecurity on the brink.
Yeah, security researchers are sounding the alarm. They're briefing clients on new kinds of threats powered by generative AI.
Like what?
Things they're calling vibe hacking, using AI to craft messages perfectly tuned to manipulate emotions or spread disinformation. Also, polymorphic malware that constantly rewrites itself to evade detection. And even zero-click exploits like Echo Leak that can compromise a device without the user doing anything.
Scary stuff.
Yeah.
And it's not just sophisticated actors.
No. They're seeing evidence of even less skilled users using jailbroken chatbots versions with safety filters removed to churn out malicious code, like harmful macros. And nation-states are definitely using AI to automate reconnaissance, scanning for vulnerabilities faster than ever.
So the takeaway for organizations, for you listening.
You absolutely must start budgeting for AI model security audits. You need to red team your large language models, test them for vulnerabilities, just like you penetration test your networks.
Because the line between writing code and writing a prompt is getting blurry.
Very thin. It creates entirely new ways to attack systems.
Okay, final area in this segment, the legal system. Courtroom AI, from draft opinions to deepfake victims.
AI is definitely making its way into American courtrooms in a lot of different ways.
Such as?
Drafting initial memos for judges, helping lawyers prepare briefs, even generating simpler, plain language motions for people representing themselves.
And there was that striking anecdote.
Ah, yes. The victim's sister, who, during a sentencing hearing, played a GenAI-generated avatar of her murdered brother. A really powerful and controversial use of the tech.
Unprecedented. But alongside these uses, there are huge risks, right? If we saw that case.
With the fabricated citations, yes.
Yeah.
2 law firms got fined $31,000 for relying on AI that just made up legal precedents. Hallucinated law.
Ouch.
It's a stark warning. Legal AI tools have to be rigorous about checking sources. Otherwise, courts could ground in unreliable junk filings.
And just quickly, on the topic of creation and sourcing Adobe Firefly.
Right. Adobe's pushed its Firefly generative AI tools onto mobile. Text-to-image, text-to-video, generative fill, all in your pocket now.
Plus collaboration tools.
Yeah, Firefly boards let teams work together, pulling in assets from various AI tools, Google's VO, OpenAI's Sora, Pika onto one canvas. But the key thing here, linking back to reliability.
Provenance.
Exactly. Every asset Firefly creates now includes content credentials embedded in it, showing how it was made. It's a good blend of powerful creativity and much-needed transparency.
Wow. Okay. We have covered a huge amount of ground.
We really have.
Just thinking back, cognitive science, photonic chips, drug discovery, cancer tests, exoskeletons, trillion-dollar infrastructure plans, sprinting robots, Pentagon deals, open-source models, cyber threats, courtroom AI.
And what stands out, again, is how it all connects. Every field touches another now.
Give us an example.
Okay, well, think about the math used in flood prediction models, LSTMs, a type of neural network good at sequences. That same underlying math helps guide the joints in those Rehab exoskeletons or those optical chips for 6G. They use transformer architecture, the same math that's revolutionizing language models, which in turn are being used to analyze complex legal documents.
It's all interwoven.
The connections are everywhere, absolutely.
Which is why AI News, June 21, 2025. It's more than just a date, isn't it? It's like the syntax of this moment we're in.
It's the keyword.
Yeah, the keyword gluing the latest AI tech news to your screen, keeping the search engines honest, and just reminding us how fast time moves in machine years.
It definitely does.
So for everyone listening,
Yeah.
stay curious, keep learning,
Yeah.
and maybe most importantly, keep your human in the loop.
That loop is still the best circuit we know.